Welcome to another episode of Sum and Products of Quadratic Roots. So in the first question, we're looking for the last coefficient, and we can actually use the fact that the sum of the products, it's going to give me negative b, so therefore alpha plus 1 must be negative 9. So we can simply solve for alpha, which is minus 5. And the product, therefore, must be equal to k. So if I just plug in negative 5 and negative 5 plus 1, I get k equals to 20. Okay, so similar to the last question, this time we're given that alpha and alpha minus 3 are two roots, but because we know what the last number is, we can write that as negative 5 over 4. So we could solve for what alpha is. I'm just going to multiply everything by 4. So I multiply this by 4. So therefore, alpha, you can factorize this, and this should be 2, 2, and then we have minus 5 and minus 1. So therefore, alpha could be a half or 5. So then, if I take alpha plus alpha minus 3, this should give me negative k over 4. And let's take each case separate. If alpha is a half, then this would be true. Therefore, this is 5 halves minus 5 halves, which will be negative 4 over 2, which is negative 2. So k will be positive 8. And if alpha is 5 instead, then we will have this, which is 7 on the left, and therefore k is minus 28. So these are two of our k values. Okay, so let's just write down what the sum is and the product. Write down the new sum, which is 9 over 7. And multiply them together. That's already the answer. So a possible equation will be this minus the sum and plus the product. And they want integer coefficient, so I multiply everything by 7 to get this equation. Okay, you know the drill. Write down the original sum and the original product. Write down the new sum. And write down the new product. I'm going to factor out the negative 2 from the middle two terms. This is a 5. So we have a negative a half plus 5 over 4 plus a 4. So let's change all of them to the same denominator. So 5 plus 16 minus 2 is 19. So a possible equation will be x squared plus 13 over 2x plus 19 over 4. Do they want integer coefficients? Yes, they do. So let's multiply everything by 4 to cancel out the fractions. There you go. All right. Original sum, original product, new sum, you can write the sum of squares as this. So we can substitute. And we have, let's do one more line, 16. And for the product, so I can write it like this. And sum of squares as this. And let's substitute. Simplify. And this is exactly 40. So we can write this as an equation, and we're done. All right, so let's just write down the original sum, original product, and answer some of these questions. The sum of squares can be written as follows. So we get 39. For the sum of cubes, we can express as follows. Substitute. Simplify. So now we want to construct a new equation with these to be the roots. So let's find the sum of this first. We cross multiply, we get this here. But we already know what the sum of cubes are. So we can just substitute from a I, and this will be the fraction. As for the product, we only have to, we can actually simplify this a little bit. So you notice that this is actually alpha square beta square over alpha beta, which is really just alpha beta. So that's -7. So an integer coefficient equation, we'll start off with the general one. It's x squared minus 230 over 7x minus a 7 equals 0. So we can cancel the denominator by multiplying 7 there. This was question 6. Question 7. Again, let's write down the original roots. So the sum is -4/3. Product is -1/3. So let's answer these two expressions. Sum of squares is as follows. So that's 22/9. You can factor out alpha beta. Now this is exactly what we just have in part I. So let's just go ahead and substitute our answer. And then we can now form the new quadratic with these roots. So we evaluate the sum, and that I'm just going to carry over. And with the product, this would look like alpha to the power 4, beta to the power 4, which can be grouped as follows. So this will be 1/81. Let's write an equation. Now multiply everything by 81. So that's the equation. All right, just 3 more. Original sum, original product. Write down the value of alpha plus beta, and we already did that. So I usually start off with that, even if the question doesn't ask specifically. And show that the sum of cubes is that. So we'll pretend we don't know what the answer is, and we will just calculate what that is and see our answer matches with theirs. So this will be -2 all cubed. It's -8 plus 18, which is 10. There you go. Oh, there's a part 3. We want the sum of the cubed reciprocals. Okay, so when we cross multiply, we get this expression. So the numerator is what we just found out on the top. So this will be 10/27. It looks like we're going to be needing that for part B. So let's find the sum of the new roots. So we already have that in the previous part, so I've just carried it over. Whereas if I multiply the two new roots, I get this fraction. So with integer coefficients, I first write down a possible solution. Now I can multiply everything by 27 to get rid of the fractions. Oh, no, that's not what I want to do. Ooh, looks like a long question. Good thing the coefficients of the square term is just 1. No, this is a, not alpha. And let me just write down the sum and the product of roots. So the original sum is positive 3, product is 1. So the sum of squares will be this. That's just 7. Sum of cubes will be, let's see, 18. Part B, that's something new. We need to show that the sum of the quartics is this. So actually, the hint is quite obvious. What you want to do is you're pretending. So you're really pretending the alpha and beta as doubled. So you take alpha square. It's like comparing to this form here. Okay, the only difference is I'm going to replace all my alphas and betas with alpha square and beta square. So this will be 2 alpha, 2 alpha square beta square, right? So let me just erase this. And then let's factor out the alpha beta as a perfect square. There. And then we can use this to actually solve what it is. So it's just continuation. So it's just from the previous line. And then this alpha square plus beta square is from part A, I. So it's from here. And then this will be minus 2 times 1 square. So we have 47. So part C, we want the sum of the new roots. So we have alpha cube plus beta cube minus alpha minus beta. I'm just going to rewrite the last 2 terms as follows, as a sum of the roots. Now this sum of cube is just this number here. And alpha plus beta is 3, so therefore this 15. The product expands to this. And let's just tidy this up. We have alpha beta to be 1, right? Yes. This is 47. So this number is this number. Alpha beta is 1 again. So we have 2 minus 47, which is minus 45. So said equation could look like this. All right, last question. So here they even ask you for the original sum and product, so let's do that. We have minus 3, minus 2. So we have the sum of the square reciprocal, cross multiply, and let's write it in terms of sums and products. Substitute. And simplify. This is I. Ooh, look at this. It's giving me a headache. All right, FOIL, alpha beta, and then we have minus a 3 over alpha, and then 3 over beta, and 9 over alpha square beta square. So let's just rearrange it a little bit. So what I'm going to do is I'm going to take away a minus 3, and the last term I'm going to group it as alpha beta square on the bottom. And let's just tidying up this part here. This is beta plus alpha over alpha beta. Now, beta plus alpha is just really alpha plus beta, so I'm not going to rewrite that. So let's just substitute what we have. On the top, we have minus 3. On the bottom, we have minus 2. Just be careful with your negatives. This is still negative. And the last term is 9 over 4. So let's just write everything on top of 4. And then we have negative 26, and then negative 17 over 4. So let's construct our equation. We have x squared minus 13 over 4x minus 17 over 4 equals 0. Do they want integer? Actually, we're not even done with the question yet. Okay, we're not done yet. These are just for part B. And then part C is to actually find out what they will be. So let's do part C. First of all, we do alpha plus. You know, I have a hunch that it is exactly what we are going to do. Come on. It's beta minus 3 over alpha squared. So I'm guessing this will be exactly what it is in part BI. So we have alpha plus beta. Okay. We're not there yet. So what does it look like? We can factor a 3. Okay, this looks awfully familiar. Aha, so this one is in part BI. Okay, not exactly the same, but nonetheless we can use what we have here. So we have minus 3 times. This is from this here. So this should be 13 over 4. And this will be negative 12 over 4, so negative 51 over 4. And then for the product, that one is exactly the same. Okay, this is exactly the same as the last part in the previous. So now we can construct an equation as well as an integer coefficient one. So times everything by 4. And there you go. Hope you enjoy that.